Alright, we are just continuing with 6B.4. We're going to do 2 more problems since we did 1 in class. So we're going to do example 2 and example 3 for this video. So, example 2, classify the quadrilateral ABCD. With vertices, A is at -2, 5. 2, 3, 4, I can't count, 5. Over here. B is at 1, 8. C is at 4, 5. And then D is at 1, 2. So we have this little shape here. So our first step is to find our slope of all of our lines. So I'm going to start with the slope of AB. Again, that's rise over run. Oh wait, never. This is C, this is D. Okay, so from A to B, rise over run. So I'm at up 3, right 3. Both of those are positive. Equal sign, which is 1. Then, the slope of BC, again, is rise over run. So from B to C, I'm going to do up or down first. I'm going to go down and left. So I went down 3, right 3. So the down one is negative, but the right one is positive. So that's -1. The slope of CD, rise over run. So from C to D, I'm going down 3, and then left 3, and left is negative. A negative divided by a negative is positive. Then the slope of DA, rise over run. From D to A, I'm going to go up 3, left 3, so that's 3 over -3. Lots of 3's in here. So a positive divided by a negative is negative, and 3 divided by 3 is 1. No. Yes. Sorry. I was reading this -1 as a negative, but that's my equal sign. Positive 1. So my first thing is, do I have any parallel sides? So that's anything with the same slope. Well, this is 1 and this is 1, so those are the same. And this is -1 and this is -1. So those are the same. So this has 2 sets of parallel sides. Then I want to check if my adjacent sides are perpendicular. I'm going to take 1, which is really 1 over 1, make it negative and flip it. This should be an arrow, not an equal sign. Alright, -1 over 1 is -1. So 1 and -1 are perpendicular. So this one is perpendicular. Now that we have perpendicular, right, now we have to decide, are all my sides the same length? So I'm going to do the distance from A to B. Right, I already have all like my slopes in there, so we don't, right, so we're just using those distances, right, to find this. So 3 squared plus 3 squared will give me x squared. So that's 9 plus 9. So x equals the square root of 18. Okay. So then I want to do BC. Well, that was -3 and +3. Again, this is the same calculation. So x equals the square root of 18. I can continue with CD, which is -3 squared. Again, same calculation. And then AD, again, same calculation. Okay, so as soon as I see that like the sides are all the same length, I know they're all gonna be the same. So where are we at in our flow chart? We found this slope. We had 2 sets of parallel sides. So we got to here. Then are they perpendicular? We said yes. And then are the sides congruent? We said yes. So we eventually got to that we have a square. Go ahead, turn to the next page. We're going to do one more example. Classify quadrilateral ABCD with vertices at 3, 6, 9, -2, 5, -8, and -5, 6. A is at 1, 2, 3, 9, 9, -2, 5, -8, and then -5, -6. So that was A, B, C, and D. Now, from your picture that you draw of that quadrilateral, you might be able to kind of tell which one it's going to be. But again, this is geometric proofs. We have to prove that it is what it is. So that means you do have to show your math work, even though if you look at it and go like, yeah, I know it's going to be this shape. Again, that's fabulous, but we do have to prove what it is. So again, we're going to start by finding the slope of all 4 sides. So the slope from A to B, again, slope is found by rise over run. Okay, going down and over. So I went down 1, 2, 3, 4, 5, 6, 7, 8. Over 1, 2, 3, 4, 5, 6. Which reduces to -4/3. Okay. Slope of BC. From B to C, we go down 1, 2, go down 6, and then left 4. Which equals 3/2. That means nothing. Right, again, because a negative divided by a negative is positive, so it's positive 3/2. The slope from C to D, right? We go up, to, left. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So up to left 10. So I should put that in that it's negative, right? Because left is negative. A positive divided by a negative is negative. And then from D to A, again, we were looking at rise over run. Up to the right, so up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right, 1, 2, 3, 4, 5, 6, 7, 8. So that's 12 over 8, which is 3 over 2. So again, we're looking first for our parallel sides. So this one is 3 over 2, and this one is 3 over 2. So those are parallel. These ones are not the same. So that means we only have one set of parallel sides. And therefore, this is a trapezoid. Okay, and again, if you look back at that flow chart, as soon as you get there, there's nowhere else to go. Right? If it's a trapezoid, it can't be anything else. Alright, we did example 4 in class, so that is it for our video. We will continue practicing these proofs tomorrow. Have a wonderful rest of your day.